So another issue that the examiners have raised over and over again is the fact that people seem to lack practical experience. And you need to be able to describe practical procedures. So, for example, you need to be clear about when you use filtration or electrolysis or precipitation. Get these words sorted in your head and think about the practicals that you've done. So, for example, when we were talking about endothermic and exothermic reactions, we know that when you add water to the anhydrous crystals, you felt heat being evolved because it was an exothermic reaction. On the other hand, you had to heat these blue crystals here to make them anhydrous, to remove the water. So that shows it's an endothermic reaction because we're having to put heat into the reaction. But you know the colour changes from blue to white and back to white again. Neutralisation. Again, we did this in class. If you remember when I demonstrated it, I used a burette, which is a long column that accurately measures out a volume, and we need equal volumes of equal concentrations of acid and alkali to make a salt plus water. Think about the colours of the indicators as well. When we made copper sulphate, remember we started off with a black powder, which was the copper oxide. We added sulfuric acid, we had a blue liquid. Think about the fact that we had to keep adding it until we had black powder left over, the copper oxide unreacted, which meant that all the sulfuric acid had reacted, and so on. Think about the practical steps. Precipitation reactions. So again, we had two clear, not necessarily colourless, but clear liquids with soluble salts inside. We added them together and a precipitate formed instantly, actually. And to remove an insoluble salt, you filter them. So we used filter paper, and if you remember, the filter paper's dried and we ended up with the salts on the filter paper. So that's precipitation. And other details that you just need to make sure you're okay with. The fact that we've got ions here, we've got lattices in ionic compounds, and when we dissolve them, remember it's the flow of ions that is the electrical current in this case. So make sure you're happy with all of this. Make sure you're happy with the cathode and the anode and what happens at each electrode, so whether they gain or lose electrons. And as I said, don't worry about these equations, but if you've got a 2 plus, then obviously you've got to add 2 negative things to it to make it neutral. Make sure you know the details though about electrolysis. Remember that it's aluminium oxide actually dissolved in cryolite. And think about the graphite cathode and anode, think about the positive and the negative in the steel case and so on. Think about electroplating and what we need in our electrolyte, and the fact that the positive ions will be moving to the negative electrode. And the electrolysis of brine. Remember, we're producing sodium hydroxide, chlorine and hydrogen, and the reason is because we've got H plus and OH minus ions in the water, and then we've got sodium and chloride ions in the brine. But again, you need to know what goes in, what comes out. Remember that you have a membrane down the middle. Now, detail about language is brought up again and again. Make sure that you know the difference between an atom, an ion, and a molecule. So return to basics as well. With ionic bonding, you know it's between a metal and a non-metal. So potassium chloride, even if you can't remember that it's an ionic compound, it's a metal and a non-metal, so it must be ionic. If it's ionic, it will contain ions. If it's covalent, it will contain molecules. So make sure you're using the correct language. So covalent bonding then, this is where we have our molecules. And remember, it's 2 non-metals. Remember the basics, and they're sharing electrons. Remember, when you've drawn dot and cross diagrams, go back and count those electrons. 1, 2, 3, 4, 5, 6, 7, 8 electrons in the outer shell, 2 for hydrogen. Make sure they have the right number at the start and at the finish. Remember as well that these bonds here in the molecules themselves are really strong. We've got electrons here that are shared between 2 positive nuclei. They're being attracted by here and here, so we've got a strong covalent bond, but then the intermolecular forces are going to be weak. And this again is where people sometimes lost marks, because they were able to talk about chlorine being a gas at room temperature and sodium chloride being a solid, and they could talk about the structure of sodium chloride and chlorine being a gas and so on. But they fell down when they were talking about chlorine-chlorine bonds being weak and easily broken, which is why it's a gas. Now that is wrong. What they should have said was that in a gas, a diatomic molecule like hydrogen or chlorine, the bond inside the molecule is strong, but the intermolecular force between the molecules is weak. So it's strong covalent bonds within the molecule, weak forces between the molecules. Thinking about analysis as well, gas chromatography. Students talked about boiling point being the reason for compounds separating. Now, at a higher level, boiling point does come into it. There's an oven that's used, but that's not why things separate. So the reason that things separate is because we have a stationary phase here, and basically some of the compounds stick to that stationary better than others, so they move through a bit more slowly if they stuck to the stationary phase. So the mobile phase is a gas that's sweeping these molecules through, but if they get stuck on the stationary phase on the way in, they move through slower, and so they come out at different times. You need to be able to interpret chromatograms here. You need to know about mass spectrometry and how this tells us it's an identification. It tells us the relative molecular mass, and also the fact that the advantages that we talked about earlier with instrumental methods. Do pause here and have a look at the practical method here for a chromatogram. You did this, and you've got to remember all the details about why you write in pencil and so on. Think about the uses of this, food additives, what they're used for and why we use them.